Okay, boys, we're going to look at the least squares regression line. This is our last lesson for the Year 12 Advanced course. Now, we've done the line of best fit, and we did that by using a ruler and drawing a line so that approximately half the points were above and half the points were below. Now, that's using our eye for accuracy. Now, there is a more accurate way of doing a regression line, and one of the most popular models is the least squares regression line. Now, it uses a line of best fit for which the squares of the distances from each point in the scatter plot to the line are minimized. So what that means is, here's one of our points. If you look at the vertical distance from the point to the line, so you can see here the vertical distance from each point to the line. We're trying to minimize the square of these distances. Okay, so we're trying to minimize the distance squared. Okay, so the line that you draw such that the distance squared is kept to a minimum is called the least squares regression line. Okay, now squaring the vertical distance can be compared to finding the area of the square. So if you look at this example, here's a little scatter plot. If I draw a vertical line to that regression line, and then I can draw a little square. If I come over here, take this point, if I draw a vertical line to the regression line, I can then draw a little square. Now, the reason we're drawing squares, of course, is because squaring a distance is the same as finding the area of a square with side lengths the same as the vertical distance from the point to the line. Okay, that's the least squares regression line. Now, of course, it's got a equation y equals mx plus c because it's a straight line. Now, m is calculated by taking the correlation coefficient r and multiplying it by the sample standard deviation for the y values of the points divided by the sample standard deviation for the x values of the points. Now, c, which is the y-intercept, is the sample mean for the y values, subtract the slope of the line multiplied by the sample mean for the x values. Okay, now that's just for your information. This equation and the other equations are not part of the syllabus. It's just there for your information. All that you're required to be able to do for the least squares regression line, according to the syllabus, is to fit a least squares regression line to the data using technology. So we're going to use a spreadsheet for that and interpret the intercept and gradient of the fitted line. And we've already looked at a bit of that before. So let's have a look at our first example. The table shows the results of a survey into the number of cigarettes people smoke during the year and the number of days they are absent from work. So here is our data. We've got to find the least squares regression line by using a calculator and a spreadsheet. Well, the calculator is actually going to give us the equation, and then you can draw the least squares regression line. And the spreadsheet will do both for you. So what I'd like you to do is to get your calculator ready, and here are the instructions. Okay, so we're going to follow these instructions together. All right, so you should have your printed notes with you, and here is my calculator. All right, so we're going to go and follow the instructions. So first of all, I'm going to go into stat mode. Actually, the first instruction is shift 1 and then 2. Well, I just want to get rid of that. That's my data entered. I'm just going to go to mode 2. That's what I would do first, mode 2. And then I want to enter the A plus BX formula, because that's the regression formula. So click on 2 there, and then I've got a clear screen. So I would adjust these notes here, and so from the textbook, it's not quite what we want. So this part here, I'm just going to cross that out for the time being. I'm going to put in mode, okay, and then 2. Or was it mode 1? Let's go back. Yeah. So if I go back here, I've got to go mode. Yeah, mode 2. Yep, and then 2 again. All right, so I've got to press 2 twice. Okay, so let's write that down. So mode 2, and then 2 again. Okay, then you're good to go. So let's put in the first row. Now, where's the first row? It's 2,000, 3,000, all the way up to 10,000. So let's put that in there. So we've got 2,000, and we've got 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, and 10,000. Okay. All right, so put in the first row there, and I'm going to use the blue keypad to go back to the top. I'm going to put in the second row of numbers there. Okay, so that's 23. Then we've got 27. We've got 54. And then we've got 49. Then we've got 63. Then we've got 81. Then we've got 107. And then we've got 128. And then we've got 147. Okay. All right, so put the data in, and according to our next instruction, we've got to go AC, so all clear. We've got to clear the data first, so let's do that. So clear the data, and then now we need to access the stat function. So we're going to go shift and then 1. Now we want the regression line, so we're going to press 5, and what we want is the A value. Okay, now the reason we want the A value is because the calculator understands the equation for the regression line as A plus BX or BX plus A. Okay, so we want the A value first, which is 1. So I'm just going to go press 1. Then you have to press equals. So it's negative 18.26. So you're going to write that down. So A is negative 18.26. I guess could we, yeah, so let's do that. So okay, so A is negative 18.26. Let's get that back. Yeah, there we go. Right, could we convert that to a fraction? Yes, we could. So minus 643 over 90. So that would be the exact value, of course. We're just going to use a decimal approximation, or negative 18 and 23 over 90. I think my calculator, if I go mode 1. Okay, now shift stat. No, I've got out of stat mode then. I have to re-put the data in. Okay, now if I put that data back in again, which I'm not going to do because I've just pressed the all clear, but I would have had to press shift. If you come back down here, shift 1 and then 5, and then press B and then equals. Should get B equals 0.0156. Okay, now understanding these A and B values, the equation is in the form y equals A plus BX or y equals BX plus A. All right, so that means this is our equation. Okay, so you just have to sub in those A and B values, and that's your equation for the median regression line. All right, so now shift, let me just try something, shift stat data. Oh no, it didn't give it back to me. Okay, so the data is gone. Anyway, so that's our equation. So just follow those instructions. The only incorrect instruction for that was mode 2 and 2 we had to replace it with. All right. Now, what about on a spreadsheet? Well, go to Microsoft. This is for Microsoft Excel, this instruction here. So enter the 2 columns in the spreadsheet, and which we've done here. And what we're going to do is select that data, and we're going to go to Insert, and then Chart, and we want the scatter plot here. Okay, just here. So I want the scatter plot. Now on the left-hand side here, I can add chart element. Right, you can see where it says trend line. So I want linear because I want the line of fit. And then if I come down here, trend line, I can choose more trend line options down here. And just scrolling down a bit, you should see that I've got the option to display the equation on the chart. Okay, so there it is. Y equals 0.0156x minus 18.256. That's all done. All right. Now, what if you had Google Sheets instead? Well, let's have a look at Google Sheets. I've put X and Y as headings here, which you don't have to. But let's just say I've got that selected. I'm going to go Insert and then Chart. All right. Now from Insert Chart, I'm then going to choose the chart that I want. Now, I don't want that line graph, so I'm going to scroll up there and I'm going to choose Scatter. Okay. Now, I'm going to customize next. So I'll click on Customize and then Series. I'll go down to Series and I can add the trend line here. So I click on the trend line and there it is. But I also want the equation. So if I scroll down a little bit, I can see the label and I can say use equation. So there's my equation there. So that's how to do it on a spreadsheet. So we've satisfied that part of the syllabus. That's all done. Okay. Now, using the regression line to make predictions. Well, that's obviously the main purpose. The regression line, the regression equation can be used to model the situation described by the data. This allows you to predict an unknown variable given a known variable. Now, when they're talking about predict, they're talking about interpolation or extrapolation. Okay, so you're basically choosing values which lie on the line of best fit, which may not be part of your original data set. Okay, now for interpolation, you're choosing a value on the line between data points, and that is a relatively reliable prediction. Now, when you're choosing values outside the data boundaries, this is called extrapolation, as we've done before, and this can sometimes be misleading and is less reliable in making predictions. We've got to be careful about that. So as a rule of thumb, the further the regression line prediction is from the original data, the less reliable the result. Now let's have a look at this example here. The graph shows the heights and mass of 10 Year 12 students. Are there any limitations to the model suggested by the least squares regression line? Well, let's just have a look. This is a pretty good model because most of the data points are very close to the line. And I could happily choose values between data points. That's interpolation, and that'd be a reasonably reliable prediction based on this model. Once I start getting beyond the data, I've got to be careful because this line suggests that the heights of the students just keep on increasing, as do the mass. Now, we all know there's a limitation to human heights. So the heights cannot increase forever as the weights cannot increase forever. So the only limitation I would say exists is that the heights and the weights cannot keep increasing. Okay, so I would say the height heights and the weights can't keep increasing. That's the only limitation to that model. Can't keep on increasing forever. There is a limitation to human height and weight. All right. Now, when we say they can't keep increasing forever, it is possible that there is someone on that line. I could extrapolate and say, yep, there's a human being who is this tall and this heavy. But, if I keep extending that line there, maybe it's getting a bit much to think there's going to be someone who's 300 centimetres or 280 centimetres. So there is some limitation to that model. Okay, moving on along. Now, you are unlikely to get a question on a spreadsheet because you won't have a computer in the exam, but you will be expected to understand what the gradient and y-intercept are for the least squares regression lines. Okay, now you've got to remember that for your least squares regression line, gradient is a rate of change. Okay, and the y-intercept is the initial value. This could be initial velocity. We've done an example of that before, or say the initial cost for starting up a business. It depends on the context. Okay, now let's have a look at an example. This table shows the results of a survey into the number of people who attend a new restaurant over a number of weeks. The least squares regression line is drawn below. Its equation is this. P is the number of people and T is the time in weeks. Okay, so here's my data. Here's my regression line. Question is, explain the meaning of the gradient for the equation of the regression line. Well, the gradient we can see is 38.1. So let's write that down. So the slope is 38.1. Okay, remember that slope is the change in the y values divided by the change in the x values. So we can write this as 38 divided by 1 because we want to have y and x. And the y values is the number of people. Okay, so 38.1 people, and the x value is weeks, isn't it? Time. So this is week. So the slope tells us that 38.1 people per week. The increase, I guess, if the rate of change for the people attending the restaurant is 38.1 people per week. So every week, an extra 38.1 people approximately are attending the restaurant. Okay, so that's what it tells you. The rate of change is 38.1 people per week. So it's increasing. Don't forget this is a positive number as well. So we say the number of people is increasing by about 38 people per week. Okay, so we could write that down. So when it says explain it. So the number of people attending the restaurant increases by 38 people per week. By approximately 38 people per week. Okay, so if you look at the data, start off with 76 after 1 week, and then, well, I guess it's not exactly, is it? Well, You can have 38 there. Yeah. It's not going to be exactly 38 every time, but close enough. So you're getting about 38 people going from week to week. So the increase is 38 people, starting off with 76 after 1 week. Now, is the equation a good model for the number of people attending the restaurant? I think it is a pretty good model because look how close the data points are to the median regression line. I think it's an excellent model. The limitation would be that there's only a certain number of seats in the restaurant, so you can't keep filling it with people. Eventually, you're going to run out of room. So I would say it's an excellent model, but obviously there's limits to the extrapolation. Okay. I'd say the model is good, right? I say no, you should probably say the equation is a good model. Okay, I'll change it up. So the equation, okay, I'll have to change colors, I think. So the equation is a good model. Right? Since the data points are so close to the line, data points are so close to the line, the limitation to the model, so I mentioned the limitation. The limitation to the model is that the number of people can't keep increasing because you're going to run out of seats. So the number of people can't keep increasing. Number of people can't keep increasing since there is a limited number of seats, since there is a limited seating capacity. Since there is a limited seating capacity. Okay. Now, just lastly, which the question didn't ask, but you could ask, what does the y-intercept stand for? So y-intercept is just here. That could be a feasible question. Now the y-intercept of the line is, according to the equation, 38.7. So you could say that at 0 weeks, okay, obviously after 1 week you've got about 38 people have increased their attendance. Maybe at the start of the time when they started measuring the people, the initial amount of people in the restaurant was 38. And then after that we had another 38 increase. So the initial amount of people in the restaurant when they started counting people, that would be the y-intercept. Okay, and that is it for the median regression line. That's the end of the Year 12 advanced course. Okay.